is part of the Distinguished Lecture Series of the European Geosciences Union and has been organized by the Department of Biology, the Department of Geosciences, and the University Museums Center. Just a few words to explain where this idea came from. So we decided to focus on science communication because we believe communicating science has a pivotal role in modern academia. And the Department of Biology and the Department of Geosciences of the University of Padua are leaders in their fields. But their aim is not only to share knowledge about the life and the earth sciences, but they also want to promote the importance of communicating science clearly and effectively to better engage with the society. So I hope this event will be the first of many other similar initiatives that our departments will organize in the future. So let me thank you once more, the head of the Department of Biology, Professor Luigi Bubacco, the head of the Department of Geosciences, Professor Nicola Surian, and the president of the University Museums Center, Professor Fabrizio Nesta, for supporting my proposal. So now let's present today's speaker. So, Terri Cook, which I thank for accepting our invitation, is a geologist by training and a science writer. Her work has appeared in Scientific American, EOS, and Lonely Planet. She now leads communications at the largest research institute at the University of Colorado and has received many awards, including the 2016 EGU Science Fellowship, Science Journalism Fellowship, and the 2019 Association of Healthcare Journalists Fellowship. So please join me in welcoming her to the stage.
Thank you so much. First, a sound check. Can everyone hear me?
Yes.
Okay. I love it when AEP actually works. So thank you so much, everyone, for the invitation. And Chiara, I was telling her last night, I was so surprised to get this invitation. It is very common for scientists to have invitations to speak all around the world. It is not common for science communicators. So it's really an honor to be here tonight. So just a couple slides of introduction. Chiara kind of gave you my professional background, but I just wanted to orient you where I grew up in the United States. And so this top circle here is Connecticut, one of the smallest states, and that's where I grew up and went to the university for my bachelor's degree near there. Then I moved over to the West Coast to California for graduate school. Then I lived in Arizona. Then I lived in Colorado, where I'm now based. Then I lived in Munich. Then I moved back to Colorado, so I've moved around quite a bit. But when I was growing up in Connecticut, I really had no idea what I wanted to be or really even if I wanted to actually grow up. But I knew that I loved science, and part of the reason for this is that I grew up in a home in Connecticut that had a meteorite, a rock from outer space, in the foundation. And because I wasn't interested in geology at the time, I don't actually have a photo of it, which is sad. But it's in the corner of the house here, just behind the tree, and it was quite large. The legend was that it had streaked across the sky, like this picture from Siberia, and landed in a farmer's field nearby. And the person who was building this house asked the farmer, hey, can I put that in the foundation of the house? So it was actually the cornerstone, which is a really important stone. So I used to spend hours in my childhood just dreaming about this rock and the adventures that it must have taken, across the solar system. And I think that sparked my passion for storytelling, and it definitely inspired my career in science communication. So before I start talking a little bit more, the number one rule for science communication is you have to understand your audience so that you can connect with them and speak directly to them. So I wanted to spend just a couple minutes, if I may, trying to find out who is here to listen to this talk. And so I was hoping you could raise your hand if you're a student here at the university. And what about if you are a postdoc or a faculty member or a researcher? Great, so it looks like a few more of those than students. Does somebody else have another role? All right. And since it's co-sponsored by biology and geology, I was wondering how many biologists are in the room? Oh, lots of biologists. Okay, and how about geoscientists? So biologists outnumber the rockhounds today. And I was also curious who likes to post about science online. It could be your own research, it could be others. So a few people. And who likes to just talk about your research. You just talk to your grandparents, you talk to your friends that you're so excited about science. Awesome. So I consider all of you drafted. You are all science communicators. So because I'm a storyteller, I wanted to kind of demonstrate how I work. And so I'm going to tell you a story today about flying fish. So once upon a time, in the Colorado River, which many of you may not have heard of, but you've probably heard of where it flows through, and that's the Grand Canyon, which is in Arizona in the United States. And this is a really important river. Its headwaters are up here in Wyoming, and then also in Colorado. And then it flows down through near the Four Corners, where Colorado, Utah, and New Mexico, and Arizona all meet. And then when it hits Arizona, it enters the Grand Canyon, which is, of course, one of the most famous geologic sites on the planet. I don't know why it keeps going. So in this river, which is really, really important in the region, not because it's the biggest, not because it has the most water, but it's really important because it flows through an incredibly dry area. So it's the only water in that area. And so because of that, there's an amazing ecosystem that has evolved. And there's this very special fish, it's called a humpback chub, that's native, so it's endemic, which means it's only found in the southwestern United States. It grows up to about 50 centimeters in length, and it evolved about 3.5 million years ago. So this fish has been there a lot longer than human beings have. It is not the prettiest fish on the planet. It's kind of homely. But one of the distinguishing features is what it's named for. It's this hump on its back, and that's why it's called the humpback chub. And even if it's not the prettiest fish, this fish thrived in the conditions, okay, in the Colorado River. So before their dams were built on the river, there were seasonal floods that would triple or even sometimes be 100 times the flow between just a few days. Temperatures in the water could fluctuate strongly, so up to 26 Celsius in summer, which is quite warm, and almost freezing in the winter. And this fish thrived in that. And the other neat thing about the Colorado River is it's named for the Spanish word Colorado, which means colored or red. And that's because when those floods come through, it picks up these muds. That's where you go. It just picks up all the mud and brings it with it. And so it's actually red when it's in high flow. So these fish thrived for more than 3 million years until we built Glen Canyon Dam. And I suspect many of you have probably heard about this. It's one of the biggest in the United States. It's 216 meters high. At the top, it's almost 500 meters wide. So it's this huge wall of cement that's blocking this beautiful river. And that was completed in 1966. And I wanted to show an aerial view. Here is the dam. And so you could get a sense of the lake that backs up behind us. So this is the second largest reservoir in the United States. It's called Lake Powell, and it's so big that you can see it from space. And when it's full, which it's not right now, but when it's full, it holds 3 times 10 to the 10 cubic meters of water. Now that sounds like a lot, but if you're like me, that doesn't really mean anything. I just go, wow, that's a big number. So I tried to put it in a scale that I could think in. And so when I do the math, one Olympic-sized swimming pool holds about 2,500 cubic meters of water. So can everybody picture an Olympic swimming pool? We just had the Olympics, so it's easier. So when I do the math, Lake Powell holds about the volume of about 12 million Olympic-sized swimming pools. So that is a lot of water. So this dam has completely changed the Colorado River. It literally is a wall right in the middle of it. And you can see that it's essentially in the center of the entire basin. So it affects everything downstream, and then it also affects the upstream because of the reservoir. So this unfortunately makes it extremely hard for these humpback chub to survive. So the cold water that comes out of the base of the dam it's freezing cold year round. And remember how we said before that they like the warm water in the summer, they like the cold water in winter. But because of the lake is so deep, the sun doesn't actually reach the bottom. And the water, when it comes out of the dam, always comes from the bottom. So it's always freezing cold year round. In addition to that, all that mud that I talked about does not come through the dam. It settles out in the lake behind the dam. And so that water that's coming out is always clear and it's always cold. And that has actually changed the base of the ecosystem there. There's an algae that now thrives there that forms the base of the ecosystem that never used to be there before the dam was in place. In addition, in those cold, clear waters, for fishing, people who like to fish, they stocked a number of fish, including this top one here is the cutthroat trout, and the bottom one is the rainbow trout. And these are really prized by people who like to fish for sport. The problem is they like to eat humpback chub, especially the babies. And so they thrive below the dam, and they actually swim downstream through the river, and they have pretty much eaten all of the humpback chub that are in the mainstem Colorado. So these poor cute humpback chub have a real problem. But there's good news, and that is there's a few side rivers, which so many of you know geologists call tributaries, that have much warmer water because they're smaller rivers. And these are places where humpback chub actually are surviving. And so biologists, the United States has spent hundreds of millions of dollars on these fish because they are listed as endangered species, so nationally endangered species. And so they're really well studied. And so the biologists have gone up all of these side creeks and figured out that, oh, places like this little Colorado River, that the humpback chub actually do really well. Their population looks pretty good there. And so in the middle of all these studies, a biologist had an idea, and there was another side creek that I put in red over here called Havasu Creek. Some of you may have seen it before. It's known for its waterfalls, so you may have seen photos of it. And so they started thinking, gosh, if the humpback chub are only in the Little Colorado River, that's really a problem for their survival. What if there's a landslide that blocks off the river and like it forms a lake and then they don't have their environment anymore? What if someone spills pollution in the river and it kills all the fish? And so they started thinking about it and say, gosh, if we could just move some of the fish over to Havasu Creek, that would double the chance that these fish could survive. And they started thinking about it and they were like, gosh, if only fish could fly. Because on a map, that looks like a short distance. But in reality, that is harsh desert with canyons. So you have to go up thousands of feet or a couple thousand meters, down a couple thousand meters to get there. So if only they could fly. Now, fortunately, people are very smart and they thought, well, actually, they can fly if we put them in a helicopter. So this is an actual picture of a delivery of flying humpback chub. So what they did is they took a bunch of fish from that first creek, Little Colorado River. They took them to New Mexico for a vacation to a fish hatchery, raised a bunch of juveniles, and then they put them in this cooler and flew them over to the second creek, Havasu Creek, and then set them free. So thousands of fish have actually been translocated by helicopter in the Grand Canyon since 2009. So I was fortunate enough, some years later, after the first translocations, to volunteer as part of a fish crew in the Grand Canyon for an article for Scientific American. And so that meant I got to hike down, got to do some crazy rapids, like that picture on the left, that's my photo. And then I got to participate as part of a team trying to monitor these fish. And it was an incredible experience, not only because of the gorgeous location and the amazing people that I was working with, but because I felt like I was really contributing to the success of these fish. And so what we did is we made camp, and we stayed there for about 8 nights. And then we sent these nets that you can see here in the bottom right overnight. And then we would get up at 5 a.m. We would hike up and over a pass so that we dropped into this beautiful creek called Chenuma Creek, which is another place where they've been translocated. And then we would find the nets, avoiding the rattlesnakes because there's a lot of those. And then we would just see what we had caught. And sometimes there were other native fish, and so we would count them and then let those go. Occasionally there was a trout, and we would have to kill it because it eats humpback chub. And then sometimes, and this was so amazing, there would be some humpback chub in the net. And so we would get ready, because they'd be swimming around, and then we would have to pull them out, measure with a ruler their length, then move them to a scale to get their weight. And then every fish that's been translocated has a tag inserted in its belly. And so we had a little tool to try to scan it and see if a number popped up on the scanner. And that meant that it had a tag in its belly, and so we'd seen that fish before. And so we would get the number, and then came the best part, and that was setting it free again. And I loved doing it so much that they eventually just gave them all to me to set free, because I would just take it. You can imagine the fish are slippery, they're flapping around, they're really muscular, so they're really hard to hold. And so I was like really scared that I would drop it or something like that. And so I would walk over and very gently kneel down and let it go in the river. And that had such an emotional impact on me that I was totally unprepared for, because here I was, just a science writer at the bottom of the Grand Canyon, helping to save an endangered species. And even though it's ugly, it's a fish that only a mother can love. I just felt this like pride, in participating in the whole process. So it was a really amazing experience, and probably the most fun article that I've ever written. And the good news is, it seems to be working. So you can see this graph here with time increasing to the right, and on the y-axis, abundance. And you can see when the translocation started happening, and then there was a little blip in 2018, but the population has stayed high, and that's a really good sign. In addition, the biologists have found some fish that didn't have the chip in their bellies. And so that means that they have actually started to reproduce in the wild, and that suggests that the population will be sustainable. However, the river is continuing to change. The entire southwestern United States is in a multi-decadal drought right now. And some of you may have even seen the photos of the lake levels dropping. And it leaves behind this bathtub ring, we call it. And that's just from minerals like calcite that when the water was there stuck to the rock. And then now that the water has come down, there's this ring, just like in a dirty bathtub. And then the water levels have dropped so low in places that a number of the boat ramps are closed. You can't launch your boats anymore. So drought is altering the entire ecosystem, fire is, and unfortunately also some invasive species. There's a plant called tamarisk that actually originates from Egypt that has come in and grows in many places on both sides of the riverbank, and it's much taller than I am, and it sucks up a lot of the water, and it makes it really hard to get on and off of shore. So that's also continuing to alter the ecosystem. And the Chenuma Creek, where I was doing the work as part of the fish crew, unfortunately a few years later had a severe wildfire. And so you can see here in this middle picture, that's what it looked like from up above with all of the green trees. And that's what it looked like after the fire. So it was really sad because between the ash that gets released and the lack of shade, and just the whole system getting messed up, almost all the humpback chub that we were monitoring did not survive, which just goes to show the importance of having these in multiple tributaries. So will the chub live happily ever after? We don't know yet, but I'm really optimistic because of the good work that people have done and because of the graph that I showed you and the success rate that's happened. And this is an amazing picture. This is where the little Colorado River with that light blue water joins the main stem. And that's how different those two rivers are, that they come together and change. So that was my story about flying fish. And I wanted to take a second and just compare my story with what might be a more traditional science talk, say at a meeting to colleagues, or even a science abstract that you might read. So the story I told you had characters, the humpback chub, a setting, the amazing Grand Canyon, a plot of sorts, a sequence of events, language that I hope was accessible, that you could understand, a beginning and an ending, just like any story, colorful language and images that I tried to include. And when you compare that to an abstract, like the one that I pulled here, that starts with the word ontogenesis, that's really hard for someone who's not an expert, of course, to understand. And the audience for that is, of course, other scientists, but lots of times when scientists communicate, they tend to defer to that style that they would use with their colleagues, or that they would actually use in writing. And so my question to you to think about tonight is, which is more engaging for non-experts? So this is an example of what you might see in a more traditional science talk. It basically tells you the story that I just told you with just a few numbers. I've circled the key one, which is the percentage of humpback chub in Havasu Creek in, I think, whatever year the study was published. And this is one of the things that I work with my scientists all the time at the lab. This was a slide that one of my scientists showed about a month ago in a presentation. And after I pulled them aside and I just said, it was a great presentation. However, this slide was terrible. And I just had to say it honestly, because it should have been probably 3 different slides. You cannot tell what the point of this slide is. To this day, I have no idea. And one of the things, in English we often say pet peeve, like one of those little things that really bothers you, is so many times at AGU or EGU or other science conferences, I've been in the room and the scientist says, well, hopefully you can read this. I hope you can see this. And it's this like teeny tiny font that nobody in the room can read. So that's why I put that down there as a joke. So all of this is way too small. There's no point to this slide. So what I'd like to talk about tonight is how can all of you as scientists and people like myself, science journalists, public information officers who work to help publicize science, often at universities, how can we bridge the gap to make sure that science that's accurate is getting out to the public? And ultimately, how can we engage more audiences and increase our impact? So I'm going to talk about one of my favorite books. This was very influential for my career. It's called Made to Stick, and it's written by 2 brothers. One is a Stanford professor, one is a businessman, a very successful businessman in the United States. And the question that they asked in this book was, how do you create an idea that sticks? And they use this very sticky tape on the cover to really emphasize that visually. And by sticks, what they're talking about is that your idea is understood, it's remembered, and it has a lasting impact. And I think that's something that applies universally. If you're a parent, you want your messages to stick there so your child will remember it. If you're a teacher or a professor, you want your messages to stick. As a science communicator, I want the same thing. So I think these are pretty universal lessons. So in this book, the Heath brothers outline 6 principles of sticky ideas. So things need to be simple, unexpected, concrete, so very specific, credible, which means believable, appeal to emotions, and tell stories. And because they really wanted to walk their talk, if you look at the first letter of each one, it spells success. And so that helps make it stick in your memory. So let's go through these one by one. So simple does not mean dumbed down. Many of the scientists that I work with, I might have just hit the wrong button here. Many of the scientists that I work with are really concerned. Scientists see such nuance and distinction in their research that they worked many years on, and they tend to get upset when it's kind of boiled down to 6th grade or 7th grade level. It just feels, I think, unfair. That's not what this means. It means finding the core idea, that essence, and trying to communicate that, and that really involves an exercise in prioritization. So both journalists, scientists, and anyone really can really get lost in the details and fail to find that central story. And it's so common in journalism that we have a saying, don't bury the lead. And that means don't get lost in all those superfluous or extra details. Really stick to that core idea. So how does this work in practice? I put an article up here that I wrote a few years ago for a magazine in the Denver area. And how many people here have heard of Red Rocks Amphitheater outside Denver? It's a really famous place for concert venues. So it's no one here, but you can see in the picture what it looks like. And so it's this outside venue with perfect acoustics that's nestled in this amazing red rock. So it's really a famous venue in the United States. And I wanted to write an article about it. In fact, I wanted to start a whole series of articles talking about the natural features in Colorado. And so I wanted to call it Colorado by Nature. And so I approached the editor. I'd written almost 200 articles for this magazine by this time, so I knew the editor really well. And I explained my idea, and she was concerned that she didn't think that the readers of the magazine would be that interested in it. She wasn't sure that we had the audience. And I said, okay, I'm gonna make you a bet. How about I write one, and I'll write about this amazing amphitheater, we'll publish it, and if it does well, then I can go ahead and have a series. And if not, then no harm done. So she agreed to the bet, and I wrote the article, and because I love to play on words, I decided to look at the list of the acts that were playing, musical acts, and so I noticed that year it was all of these retro musicians, so Hall & Oates, Neil Young, ABBA. And so the way I started the article was this summer when you're chilling out at Red Rocks listening to one of these retro acts, consider that these timeless rockers have nothing on the venue's surrounding rocks, which date back 300 million years. And so I had a lot of fun with that. And then in just 400 words, I described 300 million years of geologic history. And it really took that prioritization and simplification to do that. But basically I said there was an old mountain range that got uplifted, it got eroded down, those sediments were compacted, buried, cemented, uplifted again with the current Rocky Mountains, and eroded out, and voila, here is your Red Rocks Amphitheater. And so you can't say much more than that in 400 words. The way I ended the article was, with its amazing geologic history, this amphitheater gives a whole new meaning to the term classic rock. So it was very fun. So the next principle is unexpected. This is my personal favorite. I love to throw people off balance. And this is where you're introducing the concept of surprise. So when a pattern is broken, when your preconceived notions, your ideas that you have don't work. And it's also about creating curiosity, and that's just a gap in your knowledge that you want to fill. It's like something that you want to just itch, like a scratch that you have to itch. And it's actually what makes you keep watching a bad movie all the way to the end, even when you're pretty sure you know the ending. But it's because you're curious and you want to test that hypothesis in your head, like, is it really how it ends? And so we use the same device. And so this is my other favorite article, most favorite article that I've written for Earth Magazine, and this was about the geology of Middle Earth. So who here has seen some of the Lord of the Rings movies? Almost everyone. Great. So the core here was to discuss the geologic history of Middle Earth by talking about the film sites where they filmed the movie all across New Zealand, which of course has spawned a huge tourist industry. And the reason I did this article was to try to engage a broader audience, to get more people reading Earth Magazine than geologists or the other people who read it. And an important thing about unexpected is that the ideas should produce new insights. That's what helps make it stick and make it really memorable. And so one way I did that in writing this article was for the people who know the story, when Aragorn and the Fellowship emerged from the mines of Moria. They're sad because Gandalf just died, and Aragorn's running. And he kind of runs through a river, and he runs through this really bleached landscape that's kind of eerie. And in the article, I talk about how those two scenes, just a few seconds apart, are actually filmed on two different tectonic plates. in New Zealand, because one is north of the Alpine Fault and one is south of the Alpine Fault. And so using that movie as a device to try and surprise people and create that lasting impact. So there's many other ways that you can create this unexpectedness. This picture here is for a proposed geopark near Denver, Colorado. We have a lot of dinosaurs near us there as well. And that's, of course, not really what it looks like. This thing doesn't like it when we do it. And the mountains don't look like that. Not the entire mountains are not towering above town. And so because of that difference in proportion, you're surprised when you look at a map like this. Other ways for unexpectedness are to use metaphors. So a lava lamp, for example, is often used for convection, for plate tectonics, as well as really using eye-catching visuals to grab and hold the audience's attention. I don't know why it keeps doing that, so that's how I didn't believe it. So the cover on the left is from the Whitsunday Islands in Australia, and you can see that sensational picture that we used on the cover of Earth magazine. And I like the book on the right. It's actually a book written by the person who's the head of the Smithsonian Museum in the United States. And he talked about some of the fossils around the Denver area. And of course, Denver is known for the mountains. And here it's an ocean on the cover because that's what existed during the Cretaceous Seaway many millions of years ago. And so it really creates that sense of surprise for people who didn't know that there used to be a large ocean there. So the next two principles are concrete and credible. So concrete details make the science much more tangible and help people remember. So experiencing things with all five senses is really important for people to be able to remember it. And so journalists have a saying that's show, don't tell. So help people be immersed in the scene through the senses rather than just telling them what they're seeing. Credible is convincing information that comes from a source that's believable, that's highly respected. And fortunately, around the globe, scientists are considered credible. So that's not usually an issue for science communication. Emotions, we talked about a little bit before, but ultimately people are wired to care about living organisms. Okay, so if I show a picture of a baby panda bear, everyone goes, oh, or a baby humpback chub. and we just know inherently that that's another living organism, right? And we can relate to that. So that's great for all you biologists in the room. The problem for the geologists in the room is that people are not wired to care about rocks. So we have to work a little bit harder, but it is still possible. And then stories is the last principle. And so a lot of studies in neuroscience have shown that stories are much, much more memorable than facts alone. And the numbers are a bit disputed, but about 20 times more memorable. There was a study done at Stanford by Dr. Jennifer Aker, and what she and her team did was gave 10 one-minute presentations to an audience, and 9 of them revolved around a fact, and one of them was a story. And when they did questionnaires afterwards, what they saw was that only about 5% of people remembered the fact. That was in 9 different facts that were in these presentations. But almost 2/3 of people could recall the story. So that shows how powerful it is. And it actually shouldn't be a surprise, because story is how humans have handed knowledge from generation to generation for thousands of years. So again, it's how our brains work. So you might ask, Terry, that was a great list. It spells success, I remember that, but how does this actually work in practice? And so this is a short example that comes from a previous American president, John F. Kennedy. And in 1961, just after the first little space flight for our space program, he stood in Congress and he said this: I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. And many of you may have heard this, it's often in movies. And so So I love this as an example because it's simple, right? You have the core idea of flying someone to the moon and returning it back to the Earth. Unexpected at the time. We literally had put one human in space for 20 minutes, the United States had, and now all of a sudden we're talking about flying 3 days to the moon, and having the technology to land on the moon, and then flying back 3 days. That was a big step from a little 20-minute pod flight. So at the time, it was very unexpected. Concrete, very specific details. There was even a deadline built in. Credible. At the time, the U.S. president was considered a credible source of information. And it was very emotional for many people because there was a lot of national pride and I think also internationally because it was an accomplishment of humanity. It wasn't just one nation that accomplished this. So there were a lot of emotions involved and of course, many, many stories. I'm sure you've all seen Apollo 13 and many of the other movies. So this is a great example of how in practice it can work. So working together, using the principles that I just outlined, I believe that scientists and science journalists together, we can work to make science stick. And so I have developed Terri's top 10 tips for science communication. So I'll run through those now. The first one, which I talked about at the very beginning, is you have to define your audience first. Sometimes it's very specific. So sometimes in my work, I will target one lawmaker in the US Congress and say that's who we want to get our information to. That's who we want to read it. Sometimes it's much broader. It's anybody in the public who's interested in outer space, and space science. And you can have multiple audiences sometimes, but you always have to define it. And so just as an example, when I wrote an article for the LA Times travel section, it was about hiking up Mount Olympus with my daughter, who at the time was 12, absolutely hated hiking, but she loved mythology. And so she decided that she would suffer doing the hike to get to the top of Mount Olympus, which is of course the of the Olympic gods. And I forgot to say at the beginning, I credentialed as a science writer and also as a travel writer. So you'll see me switching between both, and the niche that I developed for myself over the years was a mix of the two. And that's where the editor, for example, would not believe that there was an audience. And I don't think I finished that story. After that article on Red Rocks appeared, there were 1,000 hits on the website in the first 2 hours. It spread like crazy, and so she never called me. She picked up the phone and called me and said, okay, you can do your series. So it was fun. We did that for a couple of years. So this one, for hiking Mount Olympus, it doesn't mean that I didn't have any science in it. It's just that the target audience was people who wanted to do hike trips in Greece with their kids. And so that's what the angle was, but it's a biosphere reserve, and so I included all kinds of information about the rocks and about the local plants as well. When I'm writing for EOS, which is the publication of the American Geophysical Union, the EGU, which some of you may actually be members of or have attended the meetings, I've written a couple hundred articles for their EOS magazine, and that audience is very specifically geoscientists, but who are not experts in that particular topic. So this article here was about paleomagnetism, and so I was writing it for all the geoscientists who are not paleomagnetists. So we had to do a lot more defining of terms in that. This is a recent article that I wrote for the Geological Society of America with my husband, and it's about geoheritage. So my husband and I have done many articles about geoheritage. This is from the Drakensberg Mountains in South Africa. And so the audience for that is the membership of the Geological Society of America. It comes a magazine, every month in the mail. So that's our first step. The second one is decide on your goal. What do you want to accomplish with the communication that you're trying to develop? So last year, my lab, Laboratory for Atmospheric and Space Physics at the University of Colorado, celebrated its 75th anniversary, which in Europe does not sound like a big number at all when you consider that your university is 800 years old. But for us, that was a big number. And so we had a goal that we wanted to try to announce the history and publicize the history, as well as our strong connection to NASA, from which we get most of our funding. And we wanted to reach new audiences, people that had not heard of LASP before. And so we started brainstorming different ways to do that, and we thought we want to reach people on our campus and we want to reach people off of our campus. So how do we do it? And one of my team members, who was an undergraduate at the university, said, oh, well, at football games, American football games, the mascot in the University of Buffalo has a NASA spacesuit and runs around in it. And I just thought, oh my gosh, let's do a space-themed football game. And the athletics had never done anything like that before. In the United States, athletics, they have like big fancy offices, on top of the building. It's really hard to talk to them and reach them. So I just started emailing, I started calling, I had meeting after meeting. We finally got them to agree that yes, we can have a space-themed football game. We can show a couple videos to highlight our lab during it. And then a few weeks later, after they said yes, we hired a very famous coach. He was a player, Deion Sanders, for anybody who follows American football. And he has a whole team of publicists. He is really all over social media. He has a movie company and everything. And so the social media following went from like 20,000 to almost 2 million in a month because of that hire. And so all of a sudden we had all these people who were super excited about football because we were winning at the time, this new coach and all of that. And so it wound up being amazingly good timing, good luck. That's sometimes part of science communication. And so we did things where I had to find an astronaut to do the opening coin toss. So we found an alumni who was also an astronaut. Chip wore his suit, and we really wanted to highlight an instrument built at our lab that just lifted off from Jupiter a couple months ago on NASA's Europa mission. So I don't know if any of you have heard about that. We wanted to promote that, and so we created a video, and then the announcer, in the announcer's voice, talked about that instrument, and we showed it on the big screen, and that is enormous. They're called jumbotrons. These screens are so big, and so that's the picture of our instrument. So it was super exciting. Everything that our team did to accomplish the goals that I talked about was create a video. So I'm hoping that we can play this, and the sound is not quite working right. So let's try. I may have to step back because I'm.
For as long as Ralphie has been running, CU Boulder has had a tradition of excellence. And for even longer, the Laboratory of Atmospheric and Space Physics has been carrying on that tradition of excellence in space science. LASP was founded at CU Boulder in 1948, a decade before NASA, our main partner. Since that time, LASP has sent instruments to every planet in the solar system and beyond, making CU Boulder the University of the Universe. And traveling along on many of those missions was Ralphie. Since the mid-1980s, LASP has engraved Ralphie on every instrument we've sent into space. In 2015, the New Horizons mission passed Pluto, carrying an instrument built at LASP by CU Boulder students and Ralphie along with it. Today, that Ralphie is more than 5 billion miles from Boulder, galloping through the solar system on her journey toward interstellar space. Out where no other mascot has roamed, she carries CU Boulder's tradition of excellence into the cosmos. For more information, go to lasp.colorado.edu.
So that was a super fun video. The mascots are a really big deal in the United States. And the University of Colorado is the only university that has a real live mascot. And it runs around the field before the start of every football game. And so we were playing off of that. And so I know for you all here not involved in American football, it might be a little bit odd. But we had 50,000 people in the stands standing up and cheering and clapping when we played that video. So we did a really good job of reaching people who would not normally hear about LASP. Oh.
For as long.
Okay. So the next tip is to try as much as possible when you're communicating about science to help people relate. And so I tried to do that in my story about the flying fish by talking about the Olympic-sized swimming pools. I wasn't super happy, to be honest, with that analogy because it's still really hard to picture 12 million swimming pools. But I was looking at the reservoirs of different sizes across Europe, and I couldn't find a very good comparison. And so I thought that was better, than 30 billion cubic meters. But I'll have to work on coming up with an even better one. And I try to use terms like that always to help people relate. This is an accelerator at our lab, and so we can basically take tiny particles of dust and ice and accelerate them to very high speeds. This room here is probably 1.5 to 2 times the size of the room that we're sitting in the auditorium, so it's a really large warehouse where they built this. And so one day I was trying to figure out, I had a tour coming up, and I just thought, how can I explain this instrument? And I calculated that we accelerate pieces of ice and dust to velocities that are double the rate at which the Earth is moving around the sun. And that may also not be super tangible. I don't exactly know how fast it is, but when I hear that, I go, wow, that's fast. So much more so than just a number of 25 meters per second or whatever the velocity was. So trying to figure out ways to help people relate is really important. Another really, really important thing that's difficult for scientists is trying to avoid jargon. So technical terms that people who are not experts do not understand. And the research really clearly shows that if someone who's not an expert sees 2 terms they don't understand, their brain just turns off. They stop listening. And so that's why it's really, really important. And in fact, acronyms, so LASP, Laboratory for Atmospheric and Space Physics, is an acronym. And so you're not supposed to use more than 1 acronym in an article. And since LASP is an acronym, that basically means that when I'm communicating, I can't use any of them. And so trying to be really careful about not using jargon. Another of my tips is to grab people's attention as much as possible. We talked about that before with unexpected. And there's different ways of doing this. So obviously anybody who's on social media knows that if you use some kind of colorful image, it will attract people's attention. Always post an image. Entire platforms like Instagram are devoted to the pictures. And these are all from the last website. The other thing that scientists don't think about sometimes is titles. So if you're giving a talk, you want to make sure that your title is really interesting. Partly, so for example, if you're going to EGU in Washington, D.C. in a few weeks, you want your colleagues to come to the talk, right, and listen to it, and they're more likely to attend if they look at the title and say, oh my gosh, that sounds really interesting. But there's also a lot of media. So at the EGU meeting coming up, there are more than 400 journalists who will be attending. And always they're looking for interesting talks to write articles about. And so if you have a title that people can relate to that don't have the technical jargon, you increase your chances of having someone actually publish the information in Scientific American or one of the many other scientific publications. So one thing that I always ask my researchers before a big meeting like EGU, I say, do you have anything that's newsworthy that you're going to be talking about or that you've published recently? And I actually send an email a couple times a year reminding them specifically what I mean. By newsworthy, it represents a major discovery, so something that's a significant leap in scientific understanding, something that's new. Is your research something with profound consequences? Maybe it settles a scientific debate, or maybe it stirs up a new debate. Maybe all of those things are newsworthy to journalists. Does your research set a record? Is there a superlative there? Is it the largest or the smallest or the fastest or the most complete study ever, most complete fossil maybe ever to date? All of those for a journalist are newsworthy. Something that's mysterious or surprising, a mystery is one of the easiest frames to construct a science article around. Just like we were talking about before, that you watch a bad movie to the end, you always will keep reading about the mystery to find out how it ends. And sometimes science happens by accident. So if you were looking for one thing and then, oh, whoa, I discovered this over here, this surprise or accidental result, that's also newsworthy. Anything that impacts people's lives in a tangible way is usually newsworthy. And like we talked about before, things that appeal to people's emotions is also newsworthy. The last one I have is quirky, and that's something different, okay, that you don't normally read about in the news. And an example of that is this painting. Have any of you seen this before from Edward Munch? Yeah, it's a pretty famous painting called Scream. And at EGU, the EGU meeting in Vienna a number of years ago, there was a scientist, an atmospheric scientist, who submitted an abstract talking about the clouds in this painting and the hypothesis of how they formed, what kind of events formed it. They thought it was a very rare occurrence of these clouds. And that is something that was quirky, something you have never seen, had they never seen in the news before. And so they had a press conference about it, and so it was really widely publicized. So another tip I have, and this sounds sometimes odd to scientists, but pitch your ideas. That's what I, as a journalist, have to do all the time. I have an idea, I talk to my editor, at this magazine or that magazine, you get to know them after a while. And just like I was telling you before about the Red Rock story, like, hey, I'd like to publish this, or have you heard of that? Scientists can do the same thing. So if you have upcoming publications, if you have something coming out in GRL that you think is newsworthy, according to the criteria that I said before, you can reach out to your publicity office at the university. In the US, we call them public information officers, or PIOs, and just say, hey, would you be interested in writing an article about this, or posting about it on social media? Any journal, you do. If something comes out in Science or Nature, that's pretty much, in my world, a slam dunk that we will write a press release and an article about it. You can also send your ideas to someone like me. If there's a science journalist whose work that you've read and you think, wow, they do a pretty good job, you can send them an email and say, I have this paper coming out in Geosciences, and would you be interested in writing an article about it? And you can also tag science journalists in social media if you're publishing, if you're posting about your own science results. And so an example of this from my work was that instrument that I was showing you the pictures of before that's on its way now to Jupiter's moon Europa. And I was talking to the head scientist, and he was telling me how they had to move it from one building to another to do some testing, and that moving it 1 kilometer between buildings was going to take the entire day because of all the steps that they have to go through to do that. And so I kind of said, well, gosh, if it takes a day to move between buildings, how are you going to get it to NASA? They had to deliver it to the Jet Propulsion Lab near Los Angeles. And he said, oh, FedEx. And I was like, what? Are you kidding? You're just using a regular packaging and delivery service for a $50 million instrument? He was like, yeah, we designed this special cart, and it has shocks, and we tie it off, and we have this purge of nitrogen to make sure that there's no contamination that's coming in. And they had it all thought out, all these steps. And I said, I bet FedEx would like to post about this on social media. And I don't know anybody at FedEx, so I started talking and asking people, and I found someone who knew someone at FedEx, and more meetings, more phone calls and emails. A month later, I had the opportunity to pitch this idea to the Vice President of Communications for FedEx. And this was a quick Zoom. I showed a couple of my beautiful pictures, told them the story, and I was speaking quickly because this is a very important and busy person. And then I kind of paused at the end and probably just took a breath. And it was like totally quiet. I thought, oh, all that work. Oh, well, he's not interested or whatever. And he then was still quiet for a couple more seconds, and then he said, this is the most interesting call I have had all month. And so, yeah, we got to work, and we managed to post it on social media. So I'm trying to wake this up at the same time. I don't know why it's not making it. And so they posted about it, not only to their employees, but on their main channels. And so millions of people heard about this instrument and labs that would not have otherwise. So never be shy about pitching your ideas. So just a few more tips about working together to increase the impact of science communication. So I would encourage all of you to work with people like me, science journalists, and public information officers like I talked about before. One of the ways to do that is through a press conference. I talked about the Edward Munch clouds before. This is one that I pitched to the EGU about the Emirates mission to Mars that our laboratory helped build. So I worked previously at the European Geosciences Union, and my job was to go through the program of 18,000 abstracts and figure out which 15 to 18 total we would feature in press conferences. And how do you think I did that? Any idea how I would search through 18,000? You think I know the answer? That's right. That's right. I didn't read all of those abstracts. That would have taken me an entire year. We use keyword searches. So again, going back to your titles, we search for words like zombie. We searched for words like elephant, some of the different animals. We had an entire list and added many to it each year. So my year, sadly, we had to add COVID to it. But we search that way, and when it pops up, then I would look at the title, and then I would, in my head, run through that newsworthy list and think, okay, this has an interesting sounding title, it looks like the research is newsworthy, and then I would look at it much more closely to see if, oh my gosh, this would be one for a press conference. And so that's how we do it, and that's why it's so important when you think about your title. And then much more common are press releases, and I'm sure your university issues these, and all that means is that, for example, one of my researchers did a study on lightning on Venus and asking me this question, does it strike at Venus? And so we wrote up this article about it, and there's something called a press portal. This is the AAAS one, where we post it, and anyone who is a registered journalist has access to it, so the public doesn't. And it happens about a week before the scientific publication comes out. And when the reason for that is that the journalists can see it, and they can write an article ahead of time and publish it at the same time that the scientific publication comes out, and that way you get maximum impact. And so press releases are a really, really common tool. And so if any of you ever have the chance to help with a press release, I really encourage you to do it. And just as a quick example, this is a press release that I wrote for the Geological Society of America, and it was about Machu Picchu, and it was a really interesting abstract submitted to that meeting where the geoscientists hypothesized that they intentionally put this major monument, and they built it on tectonic faults right where two cross. And it was really provocative. And since I like to travel, I just thought, wow, this is something that everybody around the world knows about. It's really interesting. And it's the only press release where once it was issued, we stood there and watched it spread from continent to continent to continent. And these are measured in terms of potential views. So if the New York Times has, say, 10 million followers on social media, and they post about it, that means up to 10 million people could see it. And so the potential views for that one was more than 1 billion with a B. And that's the first and only time that I've ever had that successful of a press release. But it's a really good way of getting the science out there. And you have help in doing it as well. So my second to last tip is excitement is contagious. And scientists are the most passionate people I think that I've ever met. I have been in the Christmas party for the geology department at the University of Colorado, trapped in a corner with scientists talking to me for an hour or longer about their research because they are so excited about it. And so I suspect many of you are really passionate. You have to be, right, to spend 3 or 4 or 5 years of your life researching in these topics. So tap into that. I had the honor to interview Dr. Peter Molnar on the bottom there. He won the Crawford Prize, which is the equivalent of the Nobel Prize for geosciences, but it's only given out once every 4 years, and so it's actually harder to win than a regular Nobel Prize. And so I got to interview him I also got to interview Dr. Tanya Atwater, who is the person who figured out the San Andreas Fault in California and how all that works. And what really struck me with both of them is that in childhood, both of them were exposed to nature and science. And they really developed that into their passion for careers. And so all of you, I suspect, have that passion. If you are really excited about something and you write about it or you communicate about it, everybody else is going to be excited about it as well. And last but not least, my final tip is that everyone can be a science communicator. And some of you may be skeptical, you may be saying, oh gosh, I don't know, that sounds kind of complicated, I don't know if I can tell stories, but I'm proof positive. I purposely did not tell you my credentials at the beginning because I have none. I have absolutely no training as a science writer. My undergrad degree is in archaeology from Tufts University near Boston. My favorite class was Egyptian hieroglyphics. And I loved it so much that I would run home from class and actually do my homework right away. I earned a Fulbright scholarship to go to Mexico to study Mayan glyphs, but unfortunately I had already started my master's program, and so I wound up turning that down. And I decided I would probably never get a job in archaeology, so I would be much better off to switch over to geology. So I went to the University of California, Santa Cruz, and I studied the biogeochemistry of black smoker deposits. Read this up. I published the results in Science. I learned a lot in the process, and including that academia was not my calling. That was not my goal. It wasn't what I wanted to do for my career. So then I worked as an environmental consultant, and later I taught environmental studies at a small liberal arts college. Neither of those were the right fit either, but I loved to write. I discovered that in all of those things, that was the common thread. And so that's what I just said, well, gosh, why don't I try writing in science communication? And so that has launched my career. And it just goes to show that anyone and all of you, everyone can be a science communicator. And I firmly believe if each of us does a little bit, it adds up to a lot in terms of communicating accurate science to the public. So thank you very much for your attention tonight. I want to say special thanks to the EGU Education Committee, to Chiara, Department of Biology and Geology, and the chairs who I'm honoring are here tonight, as well as Cam. So thank you very much. I'd be happy to answer questions if there are.
Thank you, Terry. This was very interesting. I enjoyed it a lot. I hope you enjoyed it too. But now, because we have some also technical issue that I let's say apologize for them, I cannot let you ask like public questions right now because we are out of time, let's say. But you are free to ask some questions to Terry during the refreshment that is going to take place here, just outside this room, in the other room next door. So please feel free to exit and go to the refreshment. And thank you all for coming. And please also feel free to go to Terry and ask her questions while you're having a glass of wine. Thank you.